Good afternoon, sir. Today we'd like to have a presentation on our report. Nowadays, schools in Hong Kong usually rank their students by the mean mark method or the standard score method as shown. However, we think these two methods are insufficient. Thereby, we are going to introduce a new method in our research. In our research, we try to use the statistical method to assign a numerical weighting to each subject, aiming to measure the relative importance of each subject. The mark of each subject of a student will then be adjusted using the set of weighting generated, and the average of the adjusted marks will be used for the ranking of students. The idea of adjusting examination marks is actually not new to us. For example, the Hong Kong Examination and Assessment Authority handled the results of school-based assessment in a similar way. The calculation of the weighting will begin in studying the method of comparing the overall performance in all other subjects. The better the performance of students in one subject, the greater will be the weighting of the respective subject. Hence, the hypothesis of our research is... Okay, first of all, we want to define these symbols as follows. The explanation of the algorithm of our new method will be subdivided into 4 steps. In step 1, we use a matrix to represent the academic results of students. Aij represents the mean mark of subject J obtained by Ij students. For example, A13 represents the mean mark of subject 3 obtained by 1-3 students. Suppose A13 is greater than A23. We claim that the performance of 1-3 students is better than that of 2-3 students. Therefore, the weighting of subject 1 should be greater than subject 2. The advantage of creating such a matrix is that if we compare the sum of all elements along each row, which is denoted by SAI, we will have an idea on which subject is performing better. But our question is, will the value of SAI represent the weighting of the respective subject? The answer is not yet. Therefore, we still have another 3 steps to go. In step 2, Bij tells us whether the performance in subject J of Ij students is better than that of all other J students. For example, if B12 is greater than 1, the exam results of 1-2 students will be better than other 2 students. The greater the value of SBI, the greater should be also the weighting of subject J. In step 3, now Cij represents a weighted value of Bij obtained in step 2. The consideration of the ratio Nij to Ni prevents the situation that some elective subjects in which only few students studying have the same weight as some other subjects in which lots of students are taking. Now, the matrix can be simplified as shown. The sum of all elements along each row, SDI, now almost represents the weighting of the respective subject. In step 4, however, since there is a weighting assigned to each subject, we still need to simplify the value of Dij with their respective weighting Wj before taking the sum. That is, the weighting of each subject Wi can be calculated using the following system of equations. We can further simplify the system of equations to the equations shown on the PowerPoint. Actually, the remaining step to go is to find the eigenvalue and the eigenvector of the matrix NTM over S. Since one of the eigenvalues of this matrix must be equal to 1, In other words, the eigenvector W will represent the weighting of each subject that we're trying to look for. Of course, we know the concept and the method to solve the eigenvector. However, since we're going to deal with the matrix of size over 10 by 10, we'll leave the calculation job to computers. Now, we try to use our new method to calculate the weights for our previous example to give further explanation to our new method. In step 1, let's consider the elements in the matrix. For example, the value of A43 is 75, which represents the mean mark of combined science obtained by those physics combined science students. Note that the sum of all elements along the row physics is the greatest value, which means that physics may have the highest weighting. However, since it is inappropriate to compare different subjects, we can't tell whether A43 represents a better performance than A42. Therefore, it is insufficient to tell whether English or ICT should have a higher weighting, so it needs some more steps. In step 2, the value of B42 is 1.18, which means the English marks obtained by those physics English students is 1.18 times the average of English marks. Hence, it is now more reasonable to claim that B42 represents a better performance than B43. In step 3, we multiply B43 in the previous matrix by 2/3, which gives the value of C43. It is because there are 2 students out of 3 students studying physics, studying combined science as well. Now, it is more sensible to say the students studying English perform better than those studying ICT, since the sum of English is higher than ICT. After solving the equation of the eigenvalues and the eigenvectors of the matrix, we obtain the following result. Actually, we've been trying to verify the new method using the various sets of data. We put one of them in the research report since the result is inspiring. In example 2, we studied the academic results of the 176 Form 4 students of our schools in the previous school year. We generated the weighting of each subject using the new method. After the calculation of the matrices N, T, and M, we generated the weightings with the help of computers. We find that the result is quite similar to our prediction, that chemistry is the most important subject, while ICT is the least important. In fact, the result is fair and reasonable, since the majority of chemistry students occupy a high position among all students, while those ICT students occupy low position. Last but not least, we think that there are actually lots of diversity in the use of the weightings, and we hope that the weighting system can be further explored and discussed. Thank you very much.